In this video, we are going to find positive integers a, b, and c such that the lowest common multiple of the three numbers is equal to their sum. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. We'll notice that both sides of the equation are symmetric. Their values do not change no matter how I arrange the order of a, b, and c. So that means I can, by symmetry, I can assume the sides follow the sequence. That a is the smallest, and then it's b, and then c is the largest number. Now from this, we can establish a bound on a plus b plus c. It is at most 3 times the largest number, which is 3c, while in terms of c, of course, the minimum is, I say it's larger than c. That's already enough, because this is the lowest common multiple. They are equal. And to make things easier, I'm going to say the LCM is just m. Let the big M equals the LCM of a, b, and c. And we know that m is between c and 3c. And by definition of LCM, this big M is a multiple of c. And so that means this big M is either 2c or 3c, because it's at most just 3 times the number c. So as a multiple, it can only be either double or triple of it. So now we have two cases. The first case is that if this big M is 3c, then we've actually reached the upper bound that we've established. Equality holds, and this only happens when a, b, and c are all equal. But then the LCM of these three numbers is just the same as c, because these three numbers are equal, so the lowest common multiple is the number itself. So there's a contradiction. Then we move on to the next case, which is that if this big M is actually 2c, then because it's also the sum, I can say that a plus b equals c. Or equivalently, big M is double of 2 times a plus b. Now I'm going to establish another bound on 2 times a plus b using our assumption. Since this expression 2 times a plus b is at most 2 times b plus b, okay, so that's 4b. And in terms of b, I can say it's larger than 2b, which is already a sufficient bound again, because then I can say, because they are just big M, and it has to be a multiple of b, so this big M equals either 3b or 4b. And now I have two cases again. Now if big M is 3b, then because this is equal to 2 times a plus b, I can try to put them together. So 2a equals b. And now from this, I can write everything in terms of a. So a equals a, b is 2a, and for c it's just a plus b, and so it's actually 3a. So I'll try to parameterize our solution. I can say it's equal to, using a parameter k, where k is a natural number. And we have this solution set, of course, and its permutations. And checking, the LCM of k, 2k, and 3k is 6k, which is exactly their sum. So this case is valid. Now we can try the other case as well. Now if big M equals to 4b, then that means we have again reached the upper bound. And so that means A equals B. And because they are equal, so C is just their sum, which is, I say, is 2A. Again, I can parameterize. K, K, and 2K. Checking. The LCM is actually just 2K, but it's actually not equal to their sum. The sum is 4K instead. So this solution is not valid. So finally, we only have one type of solution. Which can be written in the form K, 2K, 3K, where K is any natural number starting from 1, of course, and their permutations. As in, I can rearrange the order, say 2K, K, 3K, and so on. So these are the final solution. Please feel free to share your ideas in the comments. Thank you for watching. See you next time.